custom functions. And we will start with the first with the symbols. Now we will discuss about custom functions and symbols in this chapter. So every function, custom function, starts with an open parenthesis and then inside two parameters, which is separated by a comma. Then we have the sign equal and greater, which means go to. And here we have a function where we do just a sum of x and y. These symbols are used together to define and execute custom functions. Parentheses, these contain the input parameters for a function. If the parentheses are empty, like this one here, it indicates a function that requires no input arguments. And if they contain variables, like here, x and y, those parameters are the inputs the function will process. Goes to arrow, this is the function operator. It separates the input parameters left side from here, from the actual expression or logic that the function will perform on the right side from here. The function body is the actual logic or calculation that happens after you define your parameters. Functionality, it defines exactly how to compute the final value that will be returned when the function is called or invoked. We'll learn this. Variable access, any parameter defined in the parentheses on the left side become variables that you can use inside the body. So actually are two parameters, but they are variables, so they can be changed. Complex and the variable access, any parameter defined in the parentheses on the left side become variables that you can use inside the body. Structure, simple body, a single expression, ag parameter 1 plus parameter 2. Complex body, a letting block that allows you to perform multiple transformation steps before returning a final result. So it can be like a single line, as this as in this example, or it can have let in and inside some M language code. So that is all about the symbols. So let's just make a short update. So we'll make the screen. And now let's go discuss about the syntax structure. So we move forward. So we have the case 1. We have parameter 1, parameter 2. We have here below, just like that, x and y goes to x plus y. Inside we have no data type mentioned, so by default x and y will be as any type. And in case 2, we already have each parameter, and we define the data type. We need to use as always, and then to specify what the data type should this parameter be. And similar for the second one, the only difference is that in this case we already define the data type for each parameter. You can define multiple parameters with entirely different data types, for example, one text, one number, and one date within the same function. Here we have an example like different data types defined in the for the parameters, but also after the parameters defining the inputs, we have also defined the outcome as a text. So we expect the outcome to be a text. So assigning data types inside and outside the parentheses is the best practice that moves your function from generic to strictly typed. So it is best to define data type for each parameter in order to avoid any future errors, because if you do a computation between a text and a number, for sure we will get an error. And here we have just an example. So let's see what we have in this query. So above we have the custom function, because we have those brackets. We have label parameter as a text. We have count parameter as a number, and then we expect an outcome as a text. We have the goes to sign here, and then we have the statement let, where the result should be the parameter label concatenated with 2 points from the bracket and the space, and then we concatenate this. We transfer number to text from the count parameter. So basically the output will be text as it is here. And then we have the in statement and the output result, like the variable called. So let's just take the example 9. We go in our list of queries. It is here, so we'll copy it. And we will just build a blank query. We go in View Advanced Editor. And we paste our query. So after we paste the query, you can see now that here it is this icon fx. This is showing us that this is a custom function. It can be renamed very easily. We can say just function. We double click and write there function. Hit enter. And now for the first parameter label, which should be a text, as you can see here, you already see that it should be a text as it was defined in the query. So because we specify that we want the label to be text and the count to be a number, we will already have it here for label text and for count number. So we will say we can give any name we want. So I will say Canada, and then we'll give a number, we'll give 10, and we will just invoke the function. And the output will be Canada 2 points, space, and 10. So we go back. We move for the case 4. In this case, we have everything, still 2 parameters. We also have data type requested because we have used as, and we define what kind of data we want in parameter 1, similar for parameter 2, but the difference is the optional, which appears before the parameter, the second parameter. So an optional parameter allows you to create a function that works even if the user doesn't provide all the inputs. So if we will not give the second parameter, the function will still work. So key rules: by default behavior, if an optional parameter is not specified during invocation, Power Query treats its value as null. Handling nulls. You must include logic like if, then, else to handle cases where the parameter is null. Otherwise, your calculation might break. Ordering. Once you define the one optional parameter, every parameter to its right must also be marked as optional. And let's just move now with example 10. So we have here an example. We have required the value first parameter as number, then we have an optional parameter bonus value as number, and we have a let-in statement. Just a description here. If the user skips bonus value, M assign it as a null value. So we have the variable name actual bonus. If so, we have the condition here. If bonus value, which is here, equal to null, then 0, else put the bonus value. So else it will take the number from the bonus value, and the result will be second variable. It will be required value, the first parameter, plus the actual bonus, which is here, and we will call the results. Let's just take the example 10 from our list of queries. I will copy it. And we can already paste it here or here, wherever we want. So we go in view, advanced editor, and we change. We paste our new query, and now let's see what this does. So we will test here always when we have this section. Is like we test our function to see if it will work. So we will say required value, let's say 100, and then bonus, let's say 50, and if we invoke, we get the outcome 150. I will just delete this one because I changed it already, the function. And if, for example, I say only 100, and for bonus value I have nothing, I will invoke the function and I'll get 100. Case number 5. So in this case, we have an empty brackets, no parameters inside. So using a parameterless function is the best way to manage business constants. Case study: create a blank query, name it FX discount rate, go in view, open advanced editor, and paste this. So we'll just copy this one. We'll write this one because it's not hard. So let's just do this. First of all, I will just delete the other functions, invoke functions. I don't think I will, oh, it works, okay. So now I will just build a new blank query and go in view, advanced editor. I will delete the BigTrf here and I will just make like that. The sign goes to, and how much was the value? 0.10. 0.10. I will just close it. Done. And now we will just rename this as, let's say, FX discount rate. And we have two Excels, online sales and corporate deals. Of course, we may have 10 Excel files, which you will see the advantage immediately. That's how easily we will use the custom function. And you want to calculate discount and final price, etc. Using your custom function will help you to quick change everything if discount rate is changed from 10% to 20% next month. So let's just apply this to our Excel file. So we take online sales and corporate deals. So we should connect to these two Excel files. So you will find it in the description of this video. So I'm going back in Power BI, and I will connect to these Excel files. So I take corporate deals. These are just some very simple Excel files. You can see that there is only one column. So we have it. Now we go for the next one. Now we take the next one. So it should be online sales. And we say transform. So we can see we have now two tables. One has one column original price and the second one has total sales. So let's just take the first example. So we will take the discount now. We'll calculate the discount by taking the sales column multiplied with our custom function, discount rate. Notice that at the end of the discount rate function, we have this open, these two parentheses, open and close. This is important to use it. Otherwise, it will not work. We will get an error. So let's just go back in our Power BI. We have the custom function, we have the online sales, we have the column sales, and what we want now is to calculate the discount, the price, the discount of the sales, which is actually 10%. And how to do that? We can go in custom column. We'll say sales discount. And then we will add our total sales column, multiply it with our function fx. The function is already in our drop list. We'll choose it and we'll open and close parentheses and hit enter. OK. And now we have 10% discount from each sale in the left column. And to do the second example, we need the final price, original price minus original price multiplied with our function, but notice that the multiplication is separated, though mathematically I don't think it's a need, but let's do it like that. So for that we need to go in Power BI. We'll go in our corporate deals Excel file, and now we'll do same thing, custom column, and we will name this final price. And we'll use our original price column minus original price multiplied the function. So minus original price multiplied with our fx function, discount rate, close parentheses. We need to first apply those empty parentheses, and then we close the final parentheses and click OK. And here is the final price. And now imagine that, and here is the discount. Imagine that we have 10 Excel files, and tomorrow the discount will be changed from 10 percentage to 20. So you can just change it from here, or you can go in the advanced editor and change it from here. Let's see, let's say that it will be changed to 20 percentage. From 10 we change to 20, and now by default everything was changed. You can see that before was 10 percentage, now it's 20, so here is 40 instead of 20. And here also the price was changed. So this is what we can do. This is advantage if you have this kind of situation in your daily work. You can just fix everything just like that with a custom function, and all the calculations are done automatically. Okay, so we have finished with the syntax structure. Let's make an update. So we'll make this green. And we will move now forward with scenarios let and in. We have only two scenarios with the custom functions. One is when this sign of the parameters from the parentheses is above the let-in block, like it is here, it becomes automatically a reusable function, which can be applied across columns or tables. And whenever we see it inside, it means that it will just do the work only for that specific query. Here we also have an example. So we have the original price parameter as number, and then we have a let-in block. Inside the function, we use let-in for multiple step logic, and a name function as fx calculate total. This we will do it at the end after we paste the script in the advanced editor. And as you can see, we have some calculations here. We have a discount variable, original price, which is in fact the parameter multiplied with 10 percentage. We have the after discount, the original price, again the parameter, minus discount, which is here. We have the tax variable. We take the after discount, we will multiply it with 5 percentage, and the total will be after discount, which is here, plus the tax, which is here. So that will be the custom function. We have another example here, a parameter input as text, and then we have two operations. We trim text, we use the function text trim. We will take the input, and then we have another line uppercase. We use function text upper, and we take the variable trimmed, and we call the uppercase variable. So in this case, we perform two operations. First, we trim. Trim is for example, if we have a string of values or text, inside we might have spaces, and therefore with the function text trim, we just delete those spaces. They might come from various sources. They are invisible, so it is good to prepare data. This should be the first step when we start to work in Power BI, to use the trim function. Good. So we have two examples. Let's just do it. We go now in our list of queries, and we are looking for example 11, which is here. I'm going to copy the script, and I will make a new blank query. I will paste in the advanced editor, my script, click done, and we have the function, and we should name it. So we have here also description on what to do step by step. We will also need to give a name to this function, fx calculate function, calculate total. So I'm going to name like that, fx calculate total. Enter. And now whenever we create a function, a custom function, we have also the chance to test it first. So if I write here, let's say 132, and I invoke the function, I will get 124. This is basically the logic applied in our function here. Good. And now the next thing what we need to do is to go to the main table corporate deals and to add a column and select invoke custom function. Then we will select the custom function, which just define it, rename it as fx calculate total. We will choose our price column as the input, which is actually the original price. So let's just go in corporate deals, Excel. And to invoke our function now, I will just delete this example. We just go in add column and then invoke custom function. Here we can say final price. It is the name of the new column, and here we will select our custom function, which is here, and we can see it also here. So we will just select it. Then we are prompted with another option. We need to choose our column, so I'm going to choose the option column name, and from the drop list down I will select the column where I want to invoke my function and to do all the calculations. So I will click OK, and now basically we have the final price. It is calculated for each value from each cell in column final price. And for the second example, input as text, we go and take example number 12. We'll copy the query and we do same steps, or we can just go override this function. We can go in view, advanced editor, and paste everything over. And now, for example, if we want to test the function, we just need to add here a text. We will say Canada, and if I invoke the function, the text was trimmed, and also all the letters are capitals now. So this is the what happened with this query. And we go for the second scenario when our parameters are placed inside the Latin block. So we can see here an example. So the query starts with let, and then we have a code line, and then we have the sign for our custom function. We have line codes inside. We have the in from the custom function. here might be code lines, and then of course we close the whole query within, and we will cut the last variable. And in the right side we have same example as we did before, so same calculations, but notice that the the custom function is inside the query, the main query. So we are going to take example number 13 and paste it in advanced editor. So I'm going back, and maybe I should delete these ones. So I'm not allowed to delete it now because the query fx calculate total cannot be deleted because it's being referenced to another query, corporate deals. So it tells me that this is connected with the corporate deals. If I go in corporate deals, I see the column here. I see now I have errors because I changed the query a few moments ago, but if I want to be able to delete this function, I need just to delete the invoked custom function from here. And now I can just delete this one. Okay. And now we can just create a new blank query. We'll paste our query example 13. And let's see what we get. And we get the final price. We have the original price and the final price. So actually all these steps from here were applied to our table, to our column price. So let's see what else we have. We have an interesting example here. So we have two queries. We have another custom function which is inside let in, but this is interesting because we are calling out the actually the um, custom function, and it will be like a custom function even if it starts with let and finish with in as a normal query. But because we call the calculate the custom function, it will become a custom function, and then we can just take it and call it in another query. So for example, we have here a table, a source, the variable source, which will create a table from records. So from what we have here, product column, we'll have text laptop, we have price column, we have 1000 value inside, and then we have the same columns but different values. So we have two lines and two columns. And then we will invoke the outside function by its name. So it is here the name, and the function is also here. And of course, this will be the output. So basically, we'll be able to take it inside in our query. And then what it does, it will add a column from our table source, the column name final price, and for each value from the price column, it will apply our function, meaning that it will apply these two steps, and this is it. Ensure the new column is currency decimal type. So here we have a table transform column type. So we take the uh, last variable, add final column, and for the final price column, which is here, will change to decimals, type number, and that's it. So let's see how this works. So we go, for example, 14. So we'll copy our query. So it is 13, this one. We'll build a new blank query. I'll paste the script, and as you can see, it is already a function which I will name it fx calculate net. Yeah, fx. And now we press enter, and also we'll take the example 15, which is the query that will call our invoked function, and we do same thing, blank query. We paste the query inside advanced editor, click done, and we have the outcome. So basically we have all the calculations here because it just called our function from here, and we can also test the function as we want. So we can say the price is 153.34. Let's see what we get. We get the final price 173. So let's see what is happening if I'm letting some space here. Will it work? Press enter. So looks like I'm just deleting. This is working. I will refresh it. Yeah, it works. Okay. So we finished. We have finished this translating. And now we are with the invoke functions. In Power BI, we have just did an example, but we are going to also to this and do. I think we are going also to do some examples here. Yeah, one example list. So in Power BI, a simple function can take an input like a number and return a modified result like that number multiplied by 10 or multiplied to a column of values from a table. So create the function first step. So whenever we want to invoke a function, we need to create first the function. We have seen how to do that. So this example creates a function called multiply by 10. In the Power Query Editor, right click on empty space in the query pane, left side, select the query, blank query, right click in the new query and rename it to multiply by 10. So we'll give the name multiply by 10. Then we go to Home tab and click Advanced Editor. Delete everything in the window and paste this simple code. My value as number. So the my value will be the parameter. And then my value multiply with 10. Click done. You will see the query icon change to a FX symbol. To invoke the function, apply to table. Now we use this function on an existing table of data, such as list of prices. Select table where you want to use the function. Go to Add Column tab on the ribbon. Click Invoke function, custom function, and the window appears fill out these files. New column name, function query, select multiply by 10 from the drop menu, and my value parameter, choose the column from your table that contains the number you want to multiply. Click OK. A new column name result will appear, showing every number from your original column multiplied by 10. So let's do everything which was written here. So first thing we need to create a custom function, my value as number. So we go in Power BI now. We will just make the new blank query. We go in View, Advanced Editor, and here we delete what we have and we'll just make a custom function. We'll say my value, and then we say as number goes to my value as a function, as a parameter, and then we say multiply by 10. Click done, and we can see we can name this function multiplied by 10. Enter, and now we can just test the function. We can say 300. If we invoke the function, we get 3k. So it works, and now we'll just apply it wherever we want. So if we go in online sales, on the column sales, we can say add a column and invoke custom function. The new column name, it will be multiplied by 10, and I need to now to take my function. I will just click on it, so it is also here. And the last step, I need to indicate which column I want to apply our custom function, and because you have only one column, I will say total sales and click OK, and now everything is multiplied with 10. So now, my friends, we have finished with the last chapter from custom functions, part 2. So basically we are moving now for the third part. So my friends, this was all. If you liked this video, please subscribe to my channel. That will be very helpful. Thank you very much for watching my video, and I wish you all the best. Goodbye, see you next time.